Technology breakthroughs can come from strange places, and the story of the stealth ship is more odder than most. A simple photo shoot gone wrong. In the early 1980s, Lockheed was putting the finishing touches on their brand new stealth plane, the F-117 Nighthawk. Proud of their work, one of the crew whipped out his new Polaroid camera to take a photo for their archives. Except he couldn't take that photo.
Sonar automatic focusing. This camera sends out inaudible sound waves that bounce off the subject and return in a split second. The lens automatically rotates to perfect focus.
The camera was using a rudimentary form of sonar to focus on the plane, and the reflective stealth panels of the aircraft, designed to deflect radar, were likewise deflecting the sonar from the camera. Flustered, the cameraman reported to Skunkworks legend Ben Rich that the sonar camera wasn't working, sparking an idea. You know what other machine always needs to deal with sonar? That's right, submarines. After all, sonar was one of the main ways to detect underwater craft, a flaw that America now had the tools to fix. Starting small, Rich's team purchased a model submarine and added faceted fairings for sonic chamber testing. In engineering, an improvement of 1 magnitude, or 10x, is considered a huge improvement and worthy of celebration. What they discovered was an improvement in sonar return 3 orders of magnitude, or 1,000 times better, with just a simple model. Impressed, the team would go on to design a submarine with angular outer surfaces just like the F-117 to deflect sonar and dampen internal noise from the crew. Acoustic tests confirmed huge improvements in sound deadening, prompting Lockheed to approach a Navy captain at the Pentagon in charge of submarine research and development, who promptly said no. Turns out that these flarings would massively slow down the speed of the submarine and make it far less efficient in the water. It simply didn't make a good underwater craft. Thus, the project was dead in the water. Well, almost. You see, the issue wasn't that the stealth didn't work, just that it wasn't good at moving through the sea. But what about air? Engineers had recently proposed a new type of catamaran that was quick, stable, and allowed most of the craft to remain above the waves, dubbed the Small Water Area Twin Hull, or SWARF. This, plus the Lockheed stealth technology, could feasibly actually make a pretty useful and invisible ship, something that Lockheed believed in so much that when they went back to Washington to discuss the F-117 progress, they hijacked the meeting to talk only about their stealth ship idea. And it must have been quite a compelling meeting, because by the end of it, they had permission to build a secret prototype and a blank check. Thus, the Sea Shadow design was born. So you're probably wondering to yourself, how do you actually take a ship and make it invisible to radar, and as much as possible, the naked eye? When creating a ship with a diminished radar signature, the primary considerations involved countering radar beams originating from distant patrol aircraft, other ships, or sea-skimming anti-ship missiles. These beams typically emanate near or slightly above the ship's horizon, and to address this, the ship design avoids vertical surfaces that efficiently reflect those beams back to the emitter. Retroreflective right angles are eliminated to prevent a cat eyes effect, and a stealthy ship shape is achieved by incorporating a series of slightly protruding and receding surfaces in the hull and superstructure construction, reflecting away all of the radar signatures. The Sea Shadow had this in spades, with a tumble-home hull sloping inward from the waterline instead of outward, and a small waterplane area twin hull under the surface to enhance stability. There were no round surfaces, no guns, or no antenna or masts protruding to give radar or sonar any chance of reflecting. But the technology didn't just stop on the outside. The entire ship was wired with cameras to reduce the need for a large crew, with only 4 personnel needed to take it to sea. It would also have a top speed of 14.2 knots. The vessel was also so experimental that it didn't even have a rudder and relied completely on stabilizers to steer, making a docking process even more impressive. It would also contain advanced combat system prototypes for passive identification and targeting, and cutting-edge heat management technology to make it have no heat signature at all. Inside the main deck, it was split in two, starting with the top forward section containing the bridge with 4 seats, followed by the galley. Above this section there were retractable masts that could be deployed when out at remote seas for satellite connectivity. Under the bridge there was a bunk room and a crew rest area, and access to the larger double-story engine room which contained twin diesel generators. This was followed then by the payload cabin. It would have a large cutout door in the floor to access the area under the stealth ship for resupply. There would also be passengers to travel down the sides of the craft to reach the twin propeller nacelles. Now, this was a technological prototype and didn't have any weapons, but you could bet that the future versions had several different missions in mind. One of them was nuclear, but I'll get to that part in a moment. So how do you actually build a top-secret stealth ship without anyone knowing? Project with unlimited budget? Check. Cutting-edge military technology? Check. Top-secret underwater spy lab? Double check. Yes, that's right. To build this stealth ship, the military would first lend Lockheed Martin the underwater base to operate from. And I'm not kidding. It was called the Hughes Mining Barge 1, and this was a fully submergible floating barge that was originally built in the 1970s to recover sunk Soviet submarines. Parked in the Santa Cruz Islands in Southern California, 4 engineers would work in shifts in the base to slowly put together different parts of a stealth ship prototype, with the components being shipped in from 4 different builders who had no clue what they were making. In fact, not even the CEOs or high-ranking military officers overseeing the projects respectively understood the final design. Deliveries would take place at night and when the Soviet satellites were not overhead, with the crane lowering the components through the ceiling of the base when it was near the surface to keep it truly top. The submarine factory can lead to mistakes, and they had actually put the stealth propellers on the wrong way round. A quick turnaround and the craft performed perfectly. According to the Climate Online Redwood City, a crew member said, "We operated during the night with impunity. We could disappear and sneak up on whomever we wanted. Nobody thought we could do that." Plus, its design allowed it to operate in swells well beyond the ability of Coast Guard vessels. Multiple times, its escorts would have to retreat due to stormy weather, but the Sea Shadow continued to operate with no issues, with apparently even a coffee mug on the bridge not spilling in huge swells. But they didn't just test it on the water. During that period, a significant concern for vessels was the Soviet satellite X-band radar. To counter this threat, the Lockheed team employed the flat angular design inspired by the Nighthawk to redirect these signals very effectively. But to validate their approach, they conducted the tests by placing the vessel at night in a 100 by 80 foot plastic swimming pool situated in a dry lake bed in Death Valley. Utilizing a test radar system resembling a satellite threat, the team confirmed the success of their design. The ship could not be picked up by Soviet satellites. Lockheed would continue to use this design for another 7 years, keeping it top secret until 1993, when it was decided that it was time to retire the testbed project and reveal it to a shocked public. Stealth technology to the rest of the US Navy. In the mid to late 2000s, the Navy initiated the development of what was intended to be the next generation of destroyers, the Zumwalt class. For those not well versed in contemporary Navy terminology, destroyers are swift yet heavily armed warships designed to escort and safeguard other ships. The Navy harbored lofty expectations for this stealth ship project, envisioning a fleet of 32 new destroyers as the cornerstone of future naval forces. Significantly, despite being larger than the average destroyer, these ships were designed around stealth technology, rendering them more challenging to detect on radar and able to protect fleets from enemies who wouldn't see them coming, literally. The Navy invested approximately $22 billion in the project, which, unfortunately, was terminated. Nevertheless, 3 of these class destroyers were constructed, with 2 already technically completed, and the 3rd currently in the process of being built. So, why were they cancelled? This is a far more complex question, but in summary, the US military moved away from stealth ship technology. It no longer suited the doctrine of the Navy, and the vessels were built didn't have the right weapons for the right role, making them more inflexible and to fight an enemy that was improving its missile technology every day. And whatever happened to the original Sea Shadow? Well, in 2006 it was offered up to museums, but with no backers, it was put on the market to be sold for scrap. It was successfully auctioned off, and the company who bought it chopped it up to make money off the materials. Thanks so much for watching.